What are number systems and what is their significance to computers? Let's see. Right from the earliest of times, people have used various ways to count and do calculations. There was the tally marker system, which was a really simple system of keeping count using just lines. Then there was the Roman numeral system. It was introduced by the Roman Empire, and it was widely used in Europe right until the 6th century. The Roman numeral system uses symbols to represent specific values like I, V, X, L, C, D, M. I represents 1, V is 5, X is 10, L is 50, C is 100, D is 500, and M is 1000. In fact, Roman numerals are still used in some places, in some instances. For example, Super Bowl seasons is written using Roman numerals. So for example, Super Bowl 52 is written as Super Bowl L I I, 50 plus 1 plus 1, 52. So how would you write a number such as 3,303? Yes, you would write it as M, thousand, 3,000, C, 100, 300, I, 1, 2, 3, 3,303. As you can see, there was no concept of zero. They did not believe in representing nothing with a symbol. Performing calculations with large numbers was a challenge. An abacus was the tool of choice to perform calculations during those times.
Now let's look at some more modern number systems. Around the 6th century, travelers introduced the Hindu-Arabic number system to Europe. They had been using a symbol called shunya to represent 0. This made representing large numbers easy. Using a positional base 10 system, you could use 0 through 9 to represent ones, tens, hundreds, and so on. For example, 7 in the hundreds place represents 700. The 7 in the ones place represents just 7. This allows you to represent, as I mentioned earlier, large numbers in a concise way compared to the previous Roman numeral and tally systems.
Other types of number systems are binary, a base 2 number system, and it uses just 2 digits, 0 and 1. The octal number system, a base 8 system, and the hexadecimal system, a base 16 number system. Now the decimal is a base 10 number system that uses digits 0 through 9. Each digit is multiplied by 10 to the power of n, where n is 0 starting from far right, incremented by 1 as you move to the left. So say 70 is 0 times 10 to the power of 0 plus 7 times 10 to the power of 1. If there is a digit to the left of 7, it gets multiplied by 10 to the power of 2, and so on. The binary number system, however, uses base 2. So each digit gets multiplied by 2 to the power n, starting with 0 on the far right. So the first digit from the right is multiplied by 2 to the power of 0. Add to that the next digit multiplied by 2 to the power of 1. Add to that the next digit multiplied by 2 to the power of 2, and so on. So here is an example of a binary number that, when converted to a decimal, equals 70. This way, you can easily convert a binary to a decimal and vice versa.
So how are number systems important, and how do they apply to software? Computer computers cannot understand letters because the only possible inputs electronics have to work with are on and off, kind of like switches. Because off and on are the only two possibilities, they use the binary number system 1 and 0.
With 0 representing off and 1 representing on, any numerical value can be understood by the computer. Can you tell what value a 4-bit combination of on, off, on, or 1001 represents?